Yeah, so I asked you to stop here and not do the grid, the graph here, and this is the reason why I wanted to be consistent, right? So we came up with the slope of the line that has these 2 points on it, and so we went right x2, y2, x1, y1, and we used our formula to determine the slope, which is -5/3. I always make my negative go up. And then the negative reciprocal would be, right, it would turn this negative into a positive and you would have to flip it. So 3/5. So this slope right here, a line with a slope of 3/5 would actually meet at a 90 degree with this one, with this line right here. And so what I did is, and just cover this up just now, don't worry about that one. Just worry about GH. Okay, so point G is at -2, 3. So I made a big dot there and labeled it G. And then H would be at 1, -2, and I labeled that H, put a big dot, and I drew a line. So that's the line that we're talking about there that has a slope of -5/3. Okay, so think about it this way. Um, just so you know, if you have a slope, right, and the rise is up top, the run is at the bottom. I always make you bring the negative up, but a negative rise would mean that you're dropping, and a positive rise would tell you that you're going up. With the run, if you have a negative run, you'd be going to the left. If you have a positive value there, you'd be going to the right. But most of the time, this will not apply to you. I want you to always bring the negative up. So you only have to worry about whether you're going up or down, but you're really always running to the right. Okay, so let's put that to the test. Like you have this slope right here of GH. So let's try that, -5/3. Technically, if you apply this slope, we should end up on the line again. So let's try it. 1, 2, 3, 4, 5. And now a run of 3. 1, 2, 3, back on the line. So 5 down over 3 back on the line. So that should be a consistent pattern. At the same time, Mr. Dixon, what if I don't want the negative to float up? What if I wanted this? The slope of GH is equal to 5 over -3. Are these the same? Yes, they are. They are the same. They're talking about the same slope. For example, if you start here and you're using this slope, technically you're going up 5, 1, 2, 3, 4, 5, and you're going back 3 to the left because your run is negative. 1, 2, 3, you're back on the line. So they're both, one is basically going downstairs and the other one is going backwards up the stairs, so to speak. So these are the same lines, so I prefer this method, right? This one right here, always make the negative float up and then you don't have to worry about it. Now it's asking, determine the coordinates of J so that GJ is perpendicular to GH. What are we talking about there, right? Well, we want a point that will connect G and J, which will be somewhere out here, either up here or down here. But so that if you were to connect those two, this line and the resulting line would end up meeting at a 90. That's what this question is asking. Okay, so G is kind of like the common point between both of those lines. That's going to be the point of intersection. Okay, so let's use our slope of a perpendicular line starting at G, right, to give us our point that will result in a perpendicular line. So we're going to use this slope, not this one now. We're going to start at G and go up 3, 1, 2, 3, and run 5 to the right. 1, 2, 3, 4, 5, right there. And now, if you were, this is what you can label this J. That's point J. And what are the coordinates to it? It would be 3, 6. Okay? And if you were to draw a line now, like so, this is GJ, which meets at a 90 here. How do you know? Because the slope of this line is 3/5, because we use the slope to find another point. Remember, that's another benefit of knowing the slope. You can find more points on the line. And so if it's 3/5, we know that the slope of this segment we calculated is -5/3. If you look at them, they are right reciprocals of each other, and they're also the negative reciprocals of each other. And so now you know they're meeting at a 90. So to answer the question here, J would have to have coordinates of 3, 6 right here. Mr. Dirson, could I have found a different point? Absolutely. You could have, because a slope of 3/5 is the same thing as saying a slope of -3/5, because ultimately they're both positive. So what does a -3/5 mean? Well, you're going down 3, 1, 2, 3, and you're going leftward for 5 units. 1, 2, 3, 4, 5. Right? So you could have said, or this point right here is -7, 0. So, and keep in mind these lines continue indefinitely, right? So you could keep going. All right, so that's how you could do questions like these graphically, just by observation using a grid. And by the way, if you were to find the slope, these are the 2 points that are far apart, right? J is out here, and there's another one here. Like if you took these 2 coordinates and you found the slope, you should get a slope once you reduce it, that is 3/5, right? And this one, no matter which 2 points, because it's consistent, should always give you a slope of -5/3. Okay. So let's keep going. Question 4. EFGH is a parallelogram. Is a parallelogram, is it a rectangle? Justify your answer. So I'm gonna use to show you a visual of it, but we're actually I'm gonna give you the coordinates of it. So let's say you were just given the coordinates. E is equal to -1, 3. F is -3, -2. G is 0, -3. And point H is 2, 2. Okay. So how are we going to go about this? Well, we're going to take and find the different slopes that are created between these points. So if you think about it, if E is -1, 3, so that's -1, 3 right there, if that's E, and then F is -3, -2, that's F. G is 0, -3, and H is 2 and 2. Okay, if we have those points connected, the question is, mathematically speaking, would this be a rectangle? And a rectangle, as well as a square, right, has all four angles are going to be 90-degree angles. Okay, so the approach is as follows. Write this down first. So let's start here, EF. So slope of EF would be, and when you go like that, you go y2 minus y1, and then it's x2 minus -1, like that, right? So y2 minus y1, x2 minus x1, which is -1, right? So that gives you -5 over, this is a positive here, so -3 plus 1 is -2, and that's just a slope of 5 over 2. Okay. Then we're going to go and find the slope of FG. We're kind of going around the shape. FG. So FG, you're going between these 2 points. I'm going to make this my x2, y2 in this case. So y2 minus y1, x2, sorry, I'm mixing it up, right? y2 minus y1, and then x2 minus x1. This will be positive, so it's -2 plus 3, that's really 1. And this gives you a -3, which is -1/3. Okay, and you find the slope of GH. So the best thing would be, if you don't have a grid, just you can go counterclockwise, right? E, F, G, H. Just make a box somewhere on the side with the points labeled, and then you know which two to pick to find the slope for each segment, right? So GH, now it's these 2 points. I'm going to make this my x2, y2, okay? So 2 minus -3, and then it's 2 minus 0, okay? So this will give you 5 over 2, okay? And then we have the last stretch, which is EH, and that will be, you're using these 2 points right here. I'll make H my second point, so 2 minus 3 over 2 minus -1, and that will be -1 over 3. Okay, and now we look at the different slopes, and we notice that EF, so EF has the same slope as GH, right? If things have the same slope, lines are parallel. Lines are parallel. Same with this one, right? So if you want to use the proper notation, right, EF is parallel to GH, which is here. So we use the little arrows, right? And the other 2 sides, this side here is parallel to this side there. Okay, so you've got 2 sides, a pair of sides that are parallel and a pair of sides that are parallel. Now the question still remains: is this? It is a parallelogram, all right, but is it a rectangle, right? So we can conclude this: EFGH is a parallelogram because opposite sides are parallel, same slope. But EFGH, is it a rectangle? It is not a rectangle because no matter where you look, you do not see any negative reciprocals, okay? You do not see any of that happening. There's no, for example, a +3 anywhere, because flipping the 1/3 would be 3 and taking the negative would be +3. And in particular, you would want 2 adjacent sides to have the negative reciprocals, right? But none of that is here. So it is not a rectangle because adjacent sides are not perpendicular. This is the symbol, right? They don't have negative reciprocal slopes. And you're probably, you have the homework written down here. I will extend it, so the same as before, page 349. We're going to go to 3 to 6, 8, 9, 12, 13, 16, 17. So the ones I've added here, these here at the end, deal with whether or not things are either a right triangle. If it's a right triangle, you're still approaching it the same way, except for you're only going to have 3 segments, right, that you're finding the slope for. And you want to see if it's a right triangle, you should have a pair of negative reciprocal slopes. If that's the case, it is indeed a right triangle. If all of them are different, then it's just going to be what we call a scalene triangle. Scalene means all sides are different, right? And they're all at different angles. So, but the particular question will be, is it a right triangle? Okay, so make sure you try these ones so you're able to answer it. Okay, so this concludes the lesson for this section 6.2.